Critical thinking. Write an equation of a rational function whose graph has all of the following characteristics. X-intercepts at x equals 2 and x equals -3, a vertical asymptote at x equals 4, and point discontinuity at -5, 0. This is a good question because it asks us to think about point discontinuity, vertical asymptotes, which are infinite discontinuity, and x-intercepts, or values of x where y equals 0. A rational function, we can begin by doing this. F of x equals, and we put a fraction bar. That gives us the setup for a rational function. If it has a vertical asymptote at x equals 4, that means we have to have a 0 in the denominator when x equals 4. So we put in the factor x minus 4. If it has an x-intercept at x equals 2 and x equals -3, that gives us a 0 in the numerator. So x minus 2 as a factor times x plus 3. But we also have another x-intercept, which we're going to later take out as a point discontinuity, and that is the x-intercept at -5, 0. So that would be x plus 5 as a factor on top. So this rational function has an x-intercept at when x equals 2, x equals -3, and x equals -5. That means the points 2, 0, -3, 0, and -5, 0 are on this graph. And of course we have a vertical asymptote when the numerator equals 0 at x equals 4. But we want a point discontinuity at -5, 0. So how do we do that? We simply multiply top and bottom by the factor x plus 5 over x plus 5. And this will give us all we need to meet the conditions that we were given. So the function f of x equals x minus 2 times x plus 3 times x plus 5 squared over x minus 4 times x plus 5 meet the criteria that this problem gives us.